Hello guys, welcome back to Math Zone African Motives. Still working on mathematics N3, continuing from the trigonometry part that we had in this platform, working with the trigonometric equations, which is another part that is important in our syllabus. So before we check the questions that we are given that we are going to work with, I'm just going to explain one or two things that we need to understand on the solving part of our trigonometric equations. If we are to check this part, all right, so let us just have this one, trigonometric equations. So what is important basically is that you are solving for a certain value of theta. Remember, theta is our angle, the angle that you'll be given. So you are solving for theta. But solving for theta, you'll be given a certain interval, mostly taken from 0 degrees up to 360 degrees. Mostly that is where our angles are being taken from, whereby we are simply saying our theta is an element of these angles in between 0 to 360 degrees. So what we need is that you are going to first refer to the reference angle that you are going to calculate. Let us take for an example that I want to calculate or I want to solve for theta, given that sine theta is equal to 0,5 and the theta is taken from 0 to 360. The angle that you are going to, the angles that you're going to have, you're not going to have one angle, but you're going to have a lot of angles, but depending with the interval that you're given, that will determine the number of angles that you're going to have. So here we see that the sine of theta is equal to a positive. The 0,5 here is a positive. So it can be a negative or it can be positive. So why is this important? Remember, when I introduced this trigonometry, I talked about the issue of quadrants. So it follows that each and every quadrant can carry a certain reference angle, each and every quadrant, where in our previous class, I introduced this as X to say each and every quadrant is going to carry a certain angle, which is X. So let X represent our reference angle. So if X is representing our reference angle, what does it mean? It is going to mean that in the first quadrant, remember, we've got the first, the second, the third, and the fourth quadrant. In the first quadrant, the angle that we are supposed to calculate, which is theta, I talked about this in our introduction part. All right, so theta, which is the exact angle that we are talking about. So theta being the exact angle, this is the one that you are calculating. That's your exact angle. X is just a reference angle to say this is the one that is going to help us to find the theta, depending with which quadrant are you going to talk about. Remember, from the cast concept, we talked about the all part in the first quadrant, in the second quadrant, sine only being positive, in the third quadrant, only tan, in the fourth quadrant, only cos. All right, so in terms of angles now, we are going to equate these to theta is going to be equal to X. There's nothing that you're going to do here. If you still remember, on our introduction part, we talked about this part. And in the second quadrant, I said our theta is going to be given as 180 degrees minus X. This is the theta that you're calculating. So it's going to be 180 degrees minus X. We're going to have 180 degrees minus X, where X is the reference angle and theta is the exact angle that you're calculating. Also, it follows this in all of the quadrants. So in the third quadrant, without wasting much of our time, let me quickly rush here. In our third quadrant, we said we are going to have our theta as 180 plus X. X is involved in this quadrant. So theta is going to be referred as 180 degrees plus X, where X is the reference angle in this case. So X is the reference angle, theta is the exact angle. All right, then in the fourth quadrant, in this case, this is going to be our angle in the fourth quadrant, which I said previously is going to be 360 degrees minus X. So theta is going to be given as 360 degrees minus x in this case. So this is what you need to know in each and every quadrant, but also considering to say, is it a positive or a negative in terms of what you're given. So what you need whenever you are to solve a trig equation in this case, the first thing is to find the reference angle. So you are going to find the reference angle. So the reference angle is the one that you are going to refer now according to each quadrant. Are you going to add that reference angle to 180? Are you going to subtract the reference angle from 180? Are you going to subtract from 360? Or are you going to take the reference angle as it is, depending with the quadrant, which is represented by the trig that you are given here? Like I said here, our sign is positive. So where sign is positive, we are going to have our sign positive in the second quadrant and also in the first for all it's for everything. So we are going to have this positive in the first and in the second quadrant. But first, you are supposed to find the reference angle, which is reference angle is the one that we are referring as x. So we are going to write this as x. How do you find the reference angle? You simply take this part as it is, but write everything as positive. Even if this is a negative, you take it as a positive. I'm going to explain later on. So sine x is equal to 0.5. So you're going to find x, which is your reference angle in this case. So that means x is going to be equivalent to the arcsine of 0.5. That's the positive, the acute angle that you get there is your reference angle. So I want us to have this on our calculator so that we can properly see what I'm trying to say here. So from your calculator here, we need arcsine 0.5. That's shift. We go to sine here. That's arcsine 0.5 like this. We get the reference angle, which is 30 degrees. The calculator does not give you the exact angle. It gives you the reference angle. Then you are the one who is supposed to play around now with this reference angle. How are you going to obtain the exact angle? And our exact angle, according to our question, is theta. We are calculating theta in this case. So therefore, like I said, our sine is 0.5, which is a positive, and sine is positive in the first and in the second quadrant. All right, so that means in the first quadrant, our exact angle, which is theta, is going to be what? We said in the first quadrant, theta is equal to x, whereby x is our reference angle. So in this case, theta is going to be equal to x, which is what? Which is 30 degrees. All right, so that is the first answer that you're going to have. Sine is also positive in the second quadrant, so we need an answer from the second quadrant in this case. All right, so from the second quadrant, what are we going to have here? From the second quadrant, we said our theta is going to be given as 180 minus x, where x is the reference angle and our reference angle is 30 degrees. So our answer is going to be 180 minus 30 degrees, which is going to be 150 degrees. This is what you simply need to know. So in between our angles taken from 0 to 360 degrees, it means the solutions for this sine theta being equal to 0.5 will be theta is equal to 30 degrees or theta is equivalent to 150 degrees. These are the two answers that we are going to have if sine theta is 0.5, that is being a positive in this case. All right, I want you to see something. Let us take the same sign that we are talking about, but this time let us have it as a negative. Let us have the same question here, but we need to solve for sine of theta being equal to minus 0.5. What were you going to do using this application of the reference that I'm trying to explain here? This is what you're going to have. You are going to find the reference angle. The reference angle, you ignore the sign that you see here. The reference angle does not affect the sign. So you ignore this sign and write this sine of x is equal to 0.5. You ignore this sign. So meaning to say x is going to be equivalent to arcsine of 0.5. And we saw previously on our calculator that arcsine 0.5 gave us 30 degrees. So this is our reference angle in this case. This is our x representing our reference angle. So you go back to the original question now to find the theta. You go back to the original question. The sign that we are given here, it's a negative. This is what we see, it's a negative. The negative here, it gives you, or it tells you, the quadrant where sine is a negative. That is the use of this negative, where sine is a negative. And if we check on our quadrant, sine is positive here and positive here. So what does it mean? It means definitely sine is negative in the third quadrant and also negative in the fourth quadrant, because this quadrant is for tan, this quadrant is for cos. So sine there is going to be a negative. So our answers are going to be taken from these two quadrants. The third quadrant, so therefore theta, the exact angle now in the third quadrant, all right? So this is from the third quadrant. Theta is equal to 180 plus x. So it is going to be 180 degrees plus x, our reference angle, which is what? Which is 30 degrees. So if we add this, we are going to obtain something like 210 in this case. All right, we move on to the fourth quadrant, where also sine is a negative there in the fourth quadrant. So in the fourth quadrant, we said our theta is going to be given as 360 minus x, which is the reference angle. So it is going to be 360 degrees minus our reference angle, which is 30 degrees. So we are going to obtain 330 degrees. If you know this concept, you are not going to have any problems in solving these trigonometric equations. So these are the two values of theta that we are going to have if sine is negative. So therefore theta is going to be 210 or theta is going to be 330 degrees. So what is it that what we actually mean here? If you are to use your calculator, I want us to bring the calculator again so that we can see what I'm trying to say. If we are to have our calculator here, we are going to see that sine, we are saying if theta is 210 and we substitute here and we say sine 210, sine, all right, sorry, we need sine 210 like this. Our answer is minus 0.5, which is exactly what we have. If theta is 330, we must have the same answer if this theta is 330. So let us put 330 here. We must have the same answer, which is minus 0.5. So this is the same thing, minus 0.5. Whenever theta is taken in this region that we see, it must give us the exact or the same thing. That is what we are saying. When theta is what? 210 or 330 degrees, the answer is going to be a negative. So as we saw that the negative, it just tells us which quadrant to use, which quadrant are we having our answers exactly given. So this can be used even for tan, even for cos. You just need to check which quadrant are you going to work with and how do you take these angles from this part here that we are working with, like I was explaining. So let us check now our questions. We've got the first question here. All right, our first question was to solve on this part here. Let me bring it properly. So this is what we are being asked to solve on our question, to solve for theta from 0 to 360, and we are given 4 marks for that. All right, so what are we going to do in this case? If we are to check here, this one was just to scare us. This part we can simplify and obtain because we want to have a single trig, like sine theta is equal to a certain value, cos theta is equal to a certain value, or tan theta is equal to a certain value. So what can we do? We can simply work with this part first, simplify everything. So that means here we are going to have 5 sine of theta is equal to 2 sine 330 degrees. Let us just work this step by step on our calculator. Let us just try to work with this one step by step. Let me bring the calculator again. All right, so that's 2 sine 330, 2 sine, because we are not even told not to use a calculator, so you can use a calculator there, which is -1. All right, so this is okay, there's -1. Is that so? Did I use the 2 here? All right, 2 sine theta, that's a -1. Okay, then cos 240, cos 240, it's -half, which is -0.5. So we are going to multiply to -0.5 here, plus 4 cos squared 135. On your calculator, this is how you write a cos squared. You're going to have 4 cos like this. You open a bracket. So it's going to be cos 135 degrees like this. You close the bracket for cos 135, but you have to close this one that you opened first. You're going to close this bracket. You square it. That is how you represent on your calculator. So this is going to give you a 2. So that's 2 times sine 90, which is going to be the sine of 90 degrees, which is a 1. All right, so that's it. You combine everything. So what are we going to have at the end from this part? That is going to be 5 sine of theta is equal to, so you combine everything on the right hand side, you are going to obtain 2,5. All right, then we can divide by 5 so that we obtain a single trig like sine theta, cos theta, like I was explaining. So the moment you divide by 5, you are now having a single trig there. You are now having a single trig, which is sine theta is equal to 2,5 divided by 5. That will be a 0,5. So if you check, we are now back to the same type of a question that we answered here, if you still remember, where we worked the sine here, the sine of x, the sine of theta here being equal to 0,5. So you are back again, you find the reference angle. After finding the reference angle, you use the quadrants to check where sine is positive, first and second quadrant. Then you use that to find the exact value. So your answers are going to be 30 and what? 30 and 150 degrees. So this one is a repetition from the one that we worked, as we can see. So here we are going to obtain our theta being 30 degrees, or theta is equal to 150 degrees. Here it's because I worked this question as it is before this one. So I'm just taking the answers, but you are supposed to work as it is, calculate your reference angle, then use. But as you can see, this part was just for scaring us, but we just simplify that, obtain a single trig. After obtaining a single trig, therefore solve. All right, so let us check the other part here. Another question that we are given. We are now having another equation here given in terms of beta. Calculate the values of beta in this case that will satisfy the following equation from 0 to 360 degrees. All right, so here we are given cos squared beta plus tan beta plus sine squared beta is equal to 2. Remember, from our identities, we said cos squared x plus sine squared x is equal to 1, or theta here. So this one, cos squared and sine squared, is going to give us a 1. All right, so that means here we are going to have cos squared beta plus sine squared beta in this case plus the tan of beta by just rearranging being equal to 2. But this whole part that we see here is giving us a 1. So that means we are going to have 1 plus the tan of beta in this case being equal to 2. So how do I solve from this part? I can simply transpose 1 to the other side so that it becomes a negative. So the tan of beta is going to give us 2 minus 1, which is a 1. So that's it, guys. Once you're at this stage, what you're going to do is to find the reference angle. That was 4 marks. All right, you have to find the reference angle. And I said for the reference angle, you can write it in terms of what? In terms of x. The reference angle, right, in terms of x. So that means the tan of x is equal to 1. So how do I find x? X is going to be equivalent to arctan 1. So x will be, on our calculator, we are going to simply need arctan 1 of which in this case, that is shift tan 1 in this case, which is going to be 45 degrees. All right, so that is 45 degrees. So how do I find the exact angles now? I have to ask myself, from this x that I'm having here, which quadrants are we having tan? Because here we are given tan being equal to 1, which is a positive. So the value there, it's a positive. So which quadrant do we have tan being a positive? All students take calculus, or we use the cast. All right, so tan is positive in the third quadrant, tan is positive and in the all. And remember, I said in the first quadrant, theta is equal to x. in the first quadrant, theta is equal to x, and in the third quadrant, theta is equal to 180 degrees plus x. So meaning to say here we are no longer having theta. Our exact angle, it's beta. So you write the way that you are given there. So that means our beta is going to be equal to what? All right, in the first quadrant, let's take the first quadrant first to say theta is equal to x. So that means beta is equal to x, and our x is 45 degrees. All right, we move on to the other one, or beta is going to be equal to what? In the third quadrant, theta is 180 plus x, but here we are referring as beta. So it's going to be 180 degrees plus x. Our x here is 45 degrees. So if we are to add everything, we are going to obtain 225 degrees. All right, so these are the angles that you can have for beta. So therefore, our beta is equal to 45 degrees, or beta is equivalent to 225 degrees taken from 0 to 360 degrees. These are the angles that we are supposed to have. So as you can see, it's a play around type of what you need is to have a single trig like the previous part that you are supposed to obtain either sine theta is equal to cos a single trig. From a single trig, tan beta is equal to, you have a single trig. That's where you can think about now finding of the reference angle. Once you have the reference angle, compare with your quadrants. Where is that trig that you are given? Is it positive or is it negative? Check where it is positive. Where it is positive, apply the exacting part. Either you're going to add 180 or you're going to subtract that reference angle from 180. I don't know. All right. Let us check another question. Solve the following if we are given that beta ranges from 0 to 360 degrees. All right, so we are given the 2 sec beta plus 4 is equal to 0. All right, so what can we do in this case? We can simply try by all means to obtain a single trig there. It was 3 marks. All right, no problem. Let's see. So we can simply try to have a single trig again, which we can transpose 4 to this side. So we're going to have 2 sec of beta is equal to 4 to this side is going to be a negative 4. So you can divide by 2 since we are multiplying here. So that's the sec of beta is equal to negative 2. But we do not have a condition that exactly gives us a sec on our calculator. If we are to check on our calculator, because now you are referring back to the calculator to say, if I am to find arc sec, I do not have sec on this part. So I have to write in terms of sine, cos, or tan. These are the ones that I can find arc of that value. So meaning to say here we are going back and try to rewrite this in terms of those identities. So in terms of those ratios. So sec is taken from where? Remember that the sec of x was taken from 1 over cosine of x. So meaning to say here we are going to have 1 over the cosine of beta equal to negative 2. As a fraction, this is over 1. So let's get rid of the fractions, cross multiply. Negative 2 times cos beta is negative 2 cos beta in this case, which is equal to 1 times 1, which is 1. Again, we are having a cos, but this is not a single trig. We are supposed to remain with a single trig, a single cos on this side. So what can we do to remain with a single cos? We are going to divide by negative 2 both sides. So that means the cosine of beta is going to be equivalent to negative 0.5. So this is a single trig of what we have on our calculator, so we can simplify the value for beta. So as you can see, guys, these are the steps that you simply needed to obtain a single trig. After having a single trig, this is like, let's say the question was just asking you to solve this. How are you going to solve this? That is where now I was saying you are supposed to think of the reference angle. In this case, our reference angle being taken from x. So x is going to be arc cos. So it is going to be arc cos of this value, but ignore the negative. The negative there is just telling us which quadrant exactly is our cos being a negative. So here our x is going to be 60 degrees. Now you compare with this x being 60 degrees from your quadrants. Remember from the cast concept, from our cast concept, where are we having cos? Because here our cos it's a negative. Where are we having cos being a negative? Here cos is positive, and here it's positive. These are the quadrants where cos is positive. So what does it mean? It means in these quadrants, cos is going to be a negative. So we are talking about the second quadrant and the third quadrant. And I said in the second quadrant, your angle theta is going to be given as 180 minus x. In the second quadrant. In the third quadrant, your angle theta is going to be given as 180 plus x, where x represents the reference angle, our reference angle of 60 degrees. But here, our angle is beta, not theta. So we're going to write it as beta. So therefore, our beta is going to be, all right, we said our answers are in the second quadrant, 180 minus x. So it is going to be 180 minus x, our reference angle, 60 degrees. So we are going to obtain 120 degrees, or our beta is going to be in the third quadrant, which is 180 plus x. So it is going to be 180 degrees plus x, which is 60 degrees. So this is going to give us 240 degrees. All right, so these are the two values of beta. Okay, let me change this one. These are the two possible values of beta that we are going to consider, or that we are going to use, which ranges from 0 to 360 as per given instruction. All right, let us check the other part again. We have got another part here. I want us to check another question here whereby we are given again, but this time take note, we are given a bracket there. Calculate the values of x that will satisfy the equation from 0 to 360 if 3 cosine of x minus 40 is equal to this value. All right, so we need a single trig again. So how can we obtain a single trig? Here we can simply divide by what? By 3 both sides. So that will be the cosine of x minus 40 degrees. The cosine of x minus 40 degrees is equal to this value divided by 3 is going to give us 0.669 like this. All right, so I want you to be careful now on this part here, because we are having the cos of x being equal to this value. So we are having this is a single trig that we have. It's cos, this one, it's on cos, it's found on cos, so it's a single trig when it is like this. So what you need is to talk about the reference angle. So you're going to find your reference angle. Your reference angle being taken from where? From this value. So we are taking this as cos. Now, since there is x, as you can see, guys, there's x. And we know that from our reference angle, we're always using x. So we can't use x again because here there's x, unless it was theta minus 40. Therefore, you talk about x. So this time, we are going to use our reference angle. Let us just say as, we just choose any letter of our choice. You can use even theta, all right? Because here there's x now, so we can use theta as our reference angle this time. So meaning to say, we are going to say cos of theta is equal to 0.669. You take this whole part is represented by theta. So cos of theta is equal to this. So theta is going to be arc cos of 0.669. That we have the exact value for theta in degrees in this case. All right, so let us check what is going to happen from our calculator if we are to have arc cos in this case of 0.669. All right, that will be 48.01. All right, so that's 48.01 degrees. So this is the angle that we are obtaining as our reference angle, the one that we're using as x before. But yes, since there was x, I said it's now going to be difficult for us to deal with x. All right, remember what was happening from our quadrants. We now go back to the cast concept, whereby we are asking ourselves where cos is a positive, because this value here, it's a positive. So cos is a positive in the fourth and in the first quadrant, whereby in the first quadrant, your theta was equal to x, and your theta in the fourth quadrant was equal to 360 degrees minus x. But this is what is happened. Remember, our x was the reference angle, but this time the reference angle is theta. So here we are talking about 360 degrees minus theta. Here we are talking about theta in this case. So meaning to say this angle representing our actual angle, because this is the one that represents your actual angle in this case, you are going to say from the first quadrant, your actual angle of x minus 40 degrees must be equal to, in the first quadrant, we take the reference angle as it is. So we are going to take our reference angle as it is, 48.01 degrees. So we can have our x. Solve an equation, transpose to this side. That means you are going to add. So you are going to obtain 88.01 degrees. All right, so that's the first x. You move on to the second x, which is x minus 40. Our actual angle this time is x minus 40. So x minus 40 is equal to, we said cos is positive again in the fourth quadrant, which is going to be 360 minus the reference angle. So it's going to be 360 degrees minus our reference angle. Remember, our reference angle here is 48.01. So you solve the equation. So x is going to be 360 degrees minus 48.01 degrees. You transpose this to the other side so that it becomes a positive. So that's plus 40 there. So at the end, our x was going to give us 351.99 degrees. All right, so these are the two possible values of x that we needed on this question to make sense. All right, so that is how you answer these questions. It's a matter of a play around type of a question that you'll be using. All right, this one, we are given again to find beta, but this time there are two ratios or two trig. We've got cos, we've got sine. So whenever there's a cos and tan, whatever trig that you have, try to write it as a single trig again. And the single trig that we expect from cos and sine definitely is tan, because we know that tan beta is going to be equal to sine beta over the cosine of beta. So meaning to say we can have this as a single trig. So to obtain tan, we can divide by cos both sides, divide by cos beta here, divide by cos beta here. So this can cancel. You remain with the 4 equal to, remember, we are saying sine over cos is going to give us a tan. So this is going to be 2 tan of what? Tan of beta. So to find tan beta as a single trig, divide by 2 both sides. So that means that tan of beta is equal to what? Is equal to 2. Yeah, we are done once we are at this stage, guys. We are back again to the concept of the reference angle. So this one I'm just going to rush since we now have this concept. So we are going back to the concept of the reference angle, whereby x is going to be arctan of this number as a positive. So on your calculator, you are going to obtain the reference angle of arctan of 2 as 63.435. That was going to give you 435 degrees. So this is our reference angle in this case. So we are having the reference angle. And which quadrant are we going to refer in this case where tan is positive? Remember, from our cast concept, tan is positive. This is the quadrant for tan. And the other one is the all for everything in the first. And in the first quadrant, theta is equal to x. In the first quadrant, theta is equal to x. In the third quadrant, theta is equal to 180 degrees plus x. So that means we can obtain the values of beta from the first quadrant. Theta is equal to x. So beta is equal to x, which is 63.435 degrees as it is. Then we calculate another beta where tan is also positive in the third quadrant, which is 180 plus x. So this one is going to be 180 plus x, our reference angle, 63.435 degrees. All right, so this is going to give us an angle of 243.435 degrees. So that is our beta in this case. So guys, this is how you play around these questions. We can answer a lot of questions. We can play around with a lot of questions, but this one, let me just answer it because it's a little bit different from what we've been having. It's a solve part, but it's not that solve part like exactly, but it goes back to the tan concept that we've been talking about here. We are given that tan of this is equal to, 2 sine x is equal to 5 cos x, where x ranges from 0 to 360. Show that the value of sec squared is going to be equal to, all right, so we're given to show that sec squared x is going to give us 7 and 1/4, which simply means if you convert this on our calculator, it is going to give us 29/4. Let us use our calculator and see what are we supposed to have as an improper fraction? In this case, we are going to put this fraction that's shifter, this part here. So this is 7 and 1/4 like this, which is going to give us 29/4. So we must obtain 29/4 or something like that. All right. So what does it actually mean from this concept? We are not solving. We are supposed to show that sec squared is supposed to give us something like this. So if we are to check here, we are given that 2 sine of x is equal to 5 cosine of x, where we can obtain an identity for that for tan. Remember, I said you can divide by cos x both sides. By cos x both sides, we obtain sine over cos here. By obtaining sine over cos, we want tan. So this is 2 tan of x, which is equal to 5. So what about tan x? Divide by 2, divide by 2. So that means that tan of x is equal to 5/2. And this x is a positive, so meaning to say we can relate to the first quadrant. But we can't solve this one because we're asked without using a calculator. So there's no solving here. We are not finding the exact value of x, because to find the exact value of x, we have to use a calculator there. To find the exact value of x, there's a need for us to use a calculator. So meaning to say here, there's no need for us to have a calculator. So what are we going to do? Let us get back to our quadrants, because we know that tan from our SOHCAHTOA concept, remember, from our SOHCAHTOA concept, tan is opposite over adjacent. So this is opposite and this is our adjacent, which we can have in the first quadrant because this is positive. So let's say this is our x. According to this part, if this is x, our opposite to x is 5. Our adjacent is this part, which is 2. So using your Pythagoras theorem, you can find this part. Remember, okay, let us just have our Pythagoras theorem. H squared is equal to a squared plus b squared, whereby hypotenuse squared is equal to the sides 2 squared plus 5 squared. All right, so h squared is equal to 2 squared, which is 4, plus 5 squared, which is 25. So h squared is equal to, add this, that will be a 29. To find the h, introduce the square root to remove the square here. So that will be h is equal to the square root of 29. So this side is going to be the square root of 29. Why am I talking about the quadrants? Because here we want to find what is going to represent sec squared. And we understand that sec squared x is simply, it simply means sec x to the exponent of 2. That is what it means. And this sec x is 1 over cos. So it simply means we are talking about 1 over the cosine of x to the exponent of 2 in this case. So we can have the value of cos, because from our ratios here, cos is adjacent over the hypotenuse. So that means we are going to have 1 over the adjacent over hypotenuse. According to this x now, our adjacent is 2. This is our adjacent. So it's going to be 2 over the hypotenuse, which is the square root of 29. So that's the square root of 29. Everything is being squared in this case. This part is being squared. So take note of what we are having. Everything actually is being squared because we are saying it's 1 over this squared. So we are supposed to square everything like this part being squared like this. But here we can simplify direct 1 squared, that is going to be 1 over 2 squared, which is 2 times 2, that is 4, square root of 9 squared. Remember, from your sets, we said square root of a times square root of a is equal to a. So the square root of 29 times the square root of 29 should give us a 29, the number that is under the square root in this case. So this is going to give us a 29 at the end. All right, so this is what we are having. We have squared everything. This one squared, this one squared. But remember, 1 over simply means the inverse of 1 divided to a over b. Simply means b over a. 1 over a over b simply means b over a, the inverse of. So 1 over this simply means the inverse. We're going to invert this. That will be 29 over 4. And we saw that before, that 29 over 4 simply represents what? 7 and 1 over 4. So this is what they were asking us to show. So this is the value for sec squared x, as we saw that sec squared x is equal to this, and we reduced this. So this is where our sec squared x is going to end at. So it was not a solving part of a question whereby you are solving the values of x or you are determining the values of x. No, but it was important for us to have this type of a question. So let us revise as much questions as we can on our trigonometry, working with the introduction. If you didn't watch the video on the introduction, make sure that you watch that video on the introduction so that you'll be able to understand some of these techniques that we are applying. They are being taken from the introduction video. All right, that's it, guys, from Meson African Motives. Till we meet again.